Good morning, everyone. I'm Kishan Shinde, pursuing my sixth sem third year engineering in Sri Venkateshwara College of Engineering in the domain of computer science engineering with artificial intelligence. This is my introduction. Let's see today's topic image acquisition. Today's topic is image acquisition. Introduction. Images are generated by combination of illumination source and the reflection or absorption of energy from that source. Depending on the source, illumination energy is affected from or transmitted through objects. Example in first category, l- light reflected on a planar surface. Or example in second category, that is when X-rays passes through patient's body for generating a diagnostic ray film. So let's in image processing, image acquisition is defined as the action of retrieving an image from some source, usually a hardware-based source for processing. It is the first step in the workflow sequence because without an image, no processing is possible. The image is acquired and is completely unprocessed. Types of image acquisition. Three main principal sensors arrangement are used for transforming illumination energy into digital images. That is single image sensor, line image sensor, and array image sensor. Incoming energy is transformed into a voltage by combination of input electric power and sensor material that is responsive to particular type of energy being detected. The output voltage waveform is response of the sensor and a digital quantity is obtained from each sensor. Single image sensor. As a figure consists of sensing material, power in, housing, filter, and an voltage waveform out, and an energy. Energy is a light source that is falling on a sensing material which is being powered in, and a voltage waveform is being obtained from that. A filter is an material that is used in between an energy and a sensing material. To generate 2D image, we use single sensor. There has to be relative displacement in both X and Y direction. We'll see what is X and Y direction later. Single image sensor, film negative. There is a negative film is mounted on a drum whose mechanical rotation provides displacement in one dimension. The single sensor is mounted on a lead screw that provides motion in a perpendicular direction. Because mechanical motion can control with high precision, this method is inexpensive but slow way to obtain high resolution images. Combining the single sensor with motion to generate 2D images. So you can see in the diagram here, the rotating drum is given a negative film here, and the sensor is perpendicular to the film rotating. And this rotation keeps on rotating, and the sensor uh, detects and acquires the image from that. An image line out per increment of rotation and full linear displacement of sensors from left to right. Let's see next one. Line sensor or sensor strips. A geometry that is used much more efficiently than single sensor consists in an inline arrangement of sensors in form of sensor strip, as shown in the figure. A strip provides imaging elements in one direction, power and a data cable that is being used there, and a temperature sensors. These sensors are being arranged in inline arrangement next to each other. It's like an row, the sensors being arranged in a row. This is known as a line sensor, the row or a line. So if we arrange sensors in a row, so it assembles as a line. So this is known as a line sensor. This sensor is being used more than a single sensor. Let's see more about it. The motion perpendicular to the strip provides imaging in one direction as shown in the figure. The motion is perpendicular to the in one direction. The motion of an image is in one direction. So this type of arrangement is used mostly flat bed scanners. So this type of image is mostly used in flat bed scanners. So the flat bed scanners, which means that image being taken in an one dimension where only one part of a motion is captured. Sensing device with 400 or more inline sensors are possible. The imaging strips gives one line of an image at a time, and the motion of the strip completes an other dimension of a 2D two-dimensional image. One image line per increment of a linear motion. Imaged area, the linear motion, and a sensor strip. Sensor strip mounted in a ring configurations are used in medical or industrial imaging to obtain cross-sectional or a size image of three-dimensional 3D object as shown in the figure. You can see in medical or industrial imaging, we use this kind of imaging. So here the circular ring is mounted with the sensor strips, and an object is being perpendicularly passed through the strip where the image is captured in three dimension here. And rotating X-ray provides an illumination, and the sensors opposite to the source collects an X-ray energy that passes through an object. This technique is in medical or in the industrial computerization is known as in industry is known as computerized axial tomography imaging. That is called as a CAT imaging. So you can see in an diagram here, an X-ray source being given there and a sensor ring. A ring consists of a sensing material, and then 3D object is passed through this material where the X-ray passes through the 3D object and is being captured by the sensor ring where the sensor ring gives out a 3D image that is being constructed. So in an above picture, you can see the cross section of an image of a 3D object. How that image is being obtained. Sensor arrays. Figure shows that individual sensors arranged in a form of an 2D array. 2D is an consists of 2D arrays, two dimension that is having an x and y direction. Here, sensors being uh, arranged in 2D arrays, where having only two dimensions. Numerous electromagnetic and some ultrasonic sensing devices are arranged in an array format. This arrangement is found in digital cameras. So in digital cameras, whenever you take any kind of pic, that is image is obtained in only two dimension. So this is mostly found in an digital cameras where two-dimensional pics are being taken. The response of each sensor is proportional to the integral of a light energy projected onto the surface of a sensor. Response of each sensor is proportional to the integral of light energy projected onto the surface of a sensor. So, the reaction of an sensor is proportional to the integral of light energy projected. It means that the response of an or image capturing capacity of an sensor is directly proportional or is equal to the integral of light energy projected onto the surface. The amount of light energy fallen on an sensor is directly proportional to the image being captured. Since the sensor array is two-dimensional, its key advantages is that the complete image can be obtained by focusing the energy pattern onto the surface of an array. Since energy arrays is two-dimension, the key advantage is that complete image can be captured by focusing on a pattern of surface of an array. So if the light source projected on an array is completely occupied, then an image is obtained in a complete array format or whatever the size of an array is. So you can see in this diagram here, illumination light source, where a light source is falling on the second scene element, where this light source is being reflected on an imaging system or sensor material that is being obtained as a digital output image there, which is inverted. The simple image formation model consists of two forms or two dimensions. The image are of two dimension functions of a form, which is known as f of x comma y. The value or amplitude of that spatial coordinates is positive scalar quantity. When an image is generated from physical process, its intensity values are proportional to the energy radiated by the physical source. When an image is generated from a physical process, its intensity value is directly proportional to the radiation of a physical source. Now, this means that image generated from a physical process, or image being captured by the sensor, is directly proportional to the energy being radiated to the physical source, which means that the amount of energy falling on a sensor is directly proportional to the image being formed from that sensor. As a consequence, f of x comma y must be non-zero and finite. That is, f of xy should be greater than 0 and lesser than infinity. So this is the brief explanation of a topic, image acquisition. Please do like, share, and subscribe. See you in the next video. Thank you. Bye.